No problem. So, data warehousing is evolving. But what is it evolving to? It is evolving to a number of kind of standardized characteristics. And this is one of those areas that's really hard to kind of discuss with any sort of concrete basis, because what a modern data warehouse looks to organization A versus organization B is largely different. But you can usually still distill it down to kind of these three main characteristics. One, it's modular. We have this ability to bring in components and remove components as needed. An example of this may be, I'm a manufacturing organization. I am starting to implement sensors throughout my entire manufacturing process. So I have IoT needs that I need to be able to bring in near real-time sensor data and implement it inside of my data warehouse so that I can make proactive decisions based off of that near real-time data. That type of module of being able to support that real-time sensor data is not going to be universal to all organizations. And so we need a model that allows us to kind of add and swap out these components as needed. Further, we also need this kind of modularity to support our organic growth of business. Just because I don't have an IoT need today, doesn't mean I won't have one in 6 months or so on. Some of these things also change. Maybe I want to retire one of these things. So again, modularity is a very big component of a modern characteristic. And this is something that was largely impossible, if not really difficult to do in kind of the traditional data warehouse model. A lot of the things in the traditional model are very tightly coupled. You pull something out and the whole thing kind of crumbles down. Again, it's not that you can't work around those things, it's just that model was not designed to support this kind of modularity. Elastic is another characteristic here. You'll see this coming in largely from the cloud component of it, but having the ability to scale up and down, in and out, all on demand, and even potentially pause these services when not needed. It's another major component of this. And the last thing here is its ability to be fluid. And when we talk about fluid here, it's about data types and rates at which we're consuming this. It's kind of a fallover from the big data world where we have a large variety of data, a large volume of data, and potentially, very quick rates of generating this data. Again, those type of things in a traditional data warehouse are difficult to deal with, where these modern ones are designed primarily for this variety of data. It isn't just a matter of bringing in data from our operational systems any longer. It's data wherever it may live, and I need to be able to bring it in and actually obtain some level of insight out of it. So this brings us to what our base kind of components look like. Components perspective, we really have it kind of bifurcated. We have it split into two areas. We have a very distinct storage layer, and then we have a very distinct compute layer. And this is a very common kind of pattern that you see with the cloud, where we have a separation of compute and storage. So if you think of something like SQL Server is very tightly coupled here. Your storage and your compute engine are essentially the same engine. Now there are some things underneath it. Maybe our storage is put onto a SAN or something along those lines, but SQL servers need to kind of understand that structure are very tightly coupled. When we move to something, let's say like SQL Server Data Warehouse, which has been renamed, and we'll talk about that in a moment, from a cloud perspective, those things have been decoupled. The storage is separated from the compute. It allows me to then elastically change those things independent of one another. It's also what allows me to pause my compute engine while my data remains intact and even accessible in some cases. I can continue to access that data with other compute modes while maybe my data warehouse is actually offline. So this is a core concept that's important to understand, is that we typically have this separation of compute and storage. It's also important to understand from a cost perspective. Generally, storage costs in these environments is rather low. We'll be talking about Azure Data Lake here in a moment. The retail costs on Azure Data Lake are around $20 a month per terabyte of data. Rather low amount of cost there, especially compared to other enterprise kind of data solutions. But then we move over to the compute side. So if we talk about an Azure Synapse SQL pool, that pool, if we were running it 24 hours a day, may cost us thousands of dollars every month to run. So the compute side is generally expensive. The storage side is generally cheap. And so it's usually the compute side that we are targeting for kind of our elastic controls in these type of environments. But again, for our purposes, what we're discussing here today, it's just important to understand that we have a separation of storage and compute. So let's move into what is Microsoft's approach. The first thing I'd like to start with kind of discussing Microsoft's approach here is there isn't one single approach inside of Microsoft's ecosystem. We will be kind of zooming in and focusing on Azure Synapse Analytics today, and that I would say is Microsoft's preferred mode of delivering a modern data warehouse. But we have a lot of options here. It goes back to what we just talked about that modularity. We have that ability to kind of plug in other services as needed. But what do we typically see in a Microsoft-driven ecosystem? Well, we're going to see Azure Synapse Analytics. We're going to see Data Lake. We're going to see Power BI, see things like Data Factory, potentially Azure Databricks, and we'll also potentially see things like analysis services. So we'll go through kind of each one of these at a high level and kind of describe what is its purpose in this model. So first, Azure Synapse Analytics. And we'll be talking quite a bit about this later. But in general, what Azure Synapse Analytics was until fairly recently is it was just a rebranding of their SQL Data Warehouse product, which is a cloud version of their previous on-premise appliance, which was PDW, and then that was later renamed and so forth as well. But essentially, it's an MPP, so massively parallel processing data warehouse platform in the cloud based on SQL Server. That is where it kind of fits in this model for what we're talking about here is that it's primarily a replacement for a relational data warehouse. So it's our kind of classic data warehouse component here. Synapse has become a lot more than that, and we'll talk about that later. It's starting to span into more of a platform play where we have this concept of a workspace, but we're not going to spend time right now talking about that. Next major component is Azure Data Lake. This acts as a centralized storage platform. Azure Data Lake Gen 2 is based on a just standard storage account inside of Azure. So it's essentially blob storage. It's blob storage plus some. So what is that plus? Well, it adds hierarchical support. And if you don't know what that means, it's not super important, but it's essentially brings us to a file system that has the ability to support folders. Traditional blob storage does not. It's just a flat kind of container-based storage, but it gives us this concept of having folders. It's low cost, massive scale. It's also Hadoop compatible, which is very important for when we start talking about some of these other components here. But the major thing that is important to understand around Data Lake is this is a universal service across Azure. It is globally deployed, so every single Azure region has storage as part of it, and it is largely supported by every single component that you can think of inside of Azure. So you want to use, I don't know, let's say you want to use IoT Hub. IoT Hub can write data to this, or it can read data to this. And you want a third-party component? Well, guess what? It can read and write data to this component. So it becomes a universal storage platform. Next, we have Power BI. hopefully most of you know what Power BI is. It's the #1 now data visualization platform. It is huge in terms of rollout and number of users. And this kind of service continues to get integrated into this modern platform. For our purposes, it is primarily that end user visualization, but it's also important to understand that it does tie into things like data lake with its use of data flows, its use of a common data model. It also has some direct integration into the Azure Synapse stuff that we'll be talking about later. Next, we have Data Factory. This is the orchestration engine. This is our ETL engine, for a lack of a better way of describing it. It consists of our standard kind of control flow where we can move things through a workflow, as well as a fairly recent addition is this concept of visual data flows, which is really, it's kind of a misnomer here. I said it combines Databricks with Power Query, but it's really combining Azure Spark with kind of Power Query and some of the capabilities that are there in order to move data between our services. So then we have Azure Databricks. Technically, this is a third-party solution. This is not a first-party Microsoft solution. Databricks exists in other clouds as well. So there's an AWS version of Databricks. But as it says here, it's a highly optimized Spark-based analytics platform. We will be talking about this a little bit later, but it is really kind of getting overshadowed by Azure's own Spark integration into things like Synapse. But this is kind of the big data platform side of this modern data warehouse architecture. Then we have Azure Analysis Services. Was there a question? Okay, sorry. Azure Analysis Services is kind of our last major component. This acts as a semantic layer. This is also largely getting overshadowed by things like Power BI, because Power BI, as it continues to grow as a platform, is continuing to get more and more powerful, and just about everything you can do in an Azure Analysis Services you can do in Power BI plus some. All the new features in terms of tabular models tend to hit Power BI first and then flow down. But there are some very real reasons why you may still want Azure Analysis Services in your kind of modern platform. So that brings us to the miscellaneous services. You could really list just about any cloud service here, but these are the ones that we are commonly seeing in these implementations. Things like Azure Function Apps, they become a very important part of managing some of our workflow. Things like Cosmos DB is becoming an important operational database that has a global scale, and we'll talk about some new features that kind of tie into things like Synapse, using things like Event Grid to make our ETL process more event-driven instead of schedule-based. Logic apps to help us with some other workflow activities than machine learning, IoT, and then we also have tie-ins to our business-ready apps like Power Apps and Power Automate. So all of these are very common components of this kind of modern data warehouse. I did mention earlier, though, that this is meant to be modular, and it is. There's no reason why you cannot use a third party for any of these components. You don't have to go all in on Microsoft's platform. You would rather use something like Informatica instead of Data Factory. It's largely compatible with this platform, and you can plug it in. You don't want to use Databricks. You'd rather use Cloudera. Go for it. It doesn't really matter how you kind of, bring what modules work for your organization. They largely are going to work together. There are some advantages of staying, platform specific, because there will be specific optimizations and tie-ins between some of these tools that are not going to be there for the third parties in many cases. But if you have standardized, let's say on Snowflake as your data warehouse platform of choice, it works in this environment just as well as, something like Synapse SQL pools. So let's move on to what does the kind of the resulting architecture look like. So we saw that architecture diagram at the beginning. It kind of laid out what maybe a mature traditional data warehouse looks like. So what does it look like in this model? Well, it looks more modular. We have various parts in here that we can kind of pull out and swap as needed. So overall, when we're talking about Microsoft's platform, we have Azure Active Directory that acts as our security model over the top of this. All of our data movement is largely managed by something like Data Factory. We have some optional components like our Explore component here, which we're using as SQL Analytics, and we'll talk about what that is here. It's a type of SQL pool that's part of Synapse, and it's actually been renamed a few times, but it's an on-demand way of exploring our data. And then, like we said, we have things like Azure Machine Learning and so forth, and it all sits on top of this storage layer that's primarily Data Lake, and it feeds Power BI. But again, these are all modular. I don't have a machine learning component need today. Well, great. I don't deploy that because I don't need it. So how does this affect then our life cycle? Well, in a traditional life cycle, it tends to be very, very waterfall. And not just waterfall, but it tends to have some very defined paths. And this is partly why these development efforts take so long and getting to that ROI takes so long. And so this is just a sample life cycle that's taken from kind of the Kimball life cycle model. So the very, very traditional. You'll see that it's pretty linear. There is some back and forth, especially around requirements gathering. And we may even implement this in maybe a series of miniature waterfalls as we kind of go through. But again, ultimately, this is still a very strong waterfall model. What you tend to see in a modern life cycle is something that is much more iterative. So we are iterating through a number of steps. And even where we enter this kind of cycle depends on what maybe our role is within an organization. But we ingest data, we write it out, we don't worry about what it looks like. It goes out in a raw format to start with. We start exploring that. We are looking for value inside of that data. We've now identified that value. We curate it, we prepare it, we maybe train some models based off of it. We take that result, we model it into something that our end users can utilize, integrate it with other systems, and then we push it out through some sort of distribution model or visualize. And this whole process kind of works going over and over again. Again, this is meant to be somewhat modular. You know, the easy example to kind of pick on here is like the machine learning. If I don't have a machine learning aspect of this, well, then I just skip that step and just move on kind of to the next modeling stage in the visualization. But the point here is that it's meant to be much shorter cycle. These are things that should be measured in weeks, not months, not years. They generally should be quick hits that I can get out the door very, very quickly to get to some level of ROI. That ROI may not be large initially, but it's some level of ROI that I can get to very, very rapidly. And then it helps kind of justify the existence of this entire kind of process, the entire program that you're building around it. So how do we put all of this together? Well, Microsoft's attempt at putting this all together is Synapse Analytics. So as I mentioned, when Synapse Analytics was initially announced, it was largely just a rename and a rebranding of Azure SQL Data Warehouse. In general, that is still fine. Azure SQL Data Warehouse has a pretty strong position around cloud providers. There's been a number of these kind of independent analysis of these platforms, and Synapse, or what was SQL Data Warehouse, is oftentimes found to be faster and cheaper compared to those other cloud platforms. So what do we mean by the other cloud platforms? We're talking about Google Big Data, or we're talking about AWS's Redshift, and we're talking about Snowflake. Those are the three primary competitors that we're talking about in this space for the data warehouse. And in all of those cases, SQL Data Warehouse is either faster or it's cheaper or it's both. You take something like BigQuery on the Google side, it is both faster and cheaper by quite a bit. And so you position that, it's already in a very strong position. But that was then. So about a year ago, in a couple days, we have the 1-year anniversary of Azure Synapse, and a lot has changed in this year. And most of it has happened in the last 4 months. The important thing, though, I guess I want to start out with is most of the things that we're talking about with Synapse Analytics today, while it is available for you to start using, it is still in preview. It's in public preview, although there are some aspects that are still in private preview as well. But this is not a platform that has gone GA yet. I don't know that I would say that that means that you can't utilize it for a production workload. We are using it with a number of clients in production workloads, and we continue to deploy it at clients for production workloads. However, being a preview, there are bugs, there are gotchas, there's missing functionality and features. And so I'm just throwing that out there as a warning that this is still a platform that is largely in flux and is under consistent development. But so let's kind of go through what has changed. So we have Synapse Analytics. And again, when this came out, it was just a rebrand of Data Warehouse. So what is it today? Well, we start by kind of scaling out what this platform is. Is it just a data warehouse any longer, or do we start adding things to it? Well, the first thing that they added was this tightly coupled integration with Azure Data Lake storage. So Data Lake is fully integrated into this environment, and the environment is somewhat content aware. I can understand things like common data model. If you're not familiar with what common data model is, it's a universal kind of way of describing data. It originally came out of a common data initiative that Microsoft did with Adobe and Salesforce, I believe, or maybe it was SAP. It was one of those companies, but they're coming up with a way of being able to share data models between these various platforms in a common way. It's also the underpinning that Power BI uses in its data flow engine is common data model. So we have the ability to read that data. We have the ability to write to that data. There's an enterprise security layer applied to this. And as we kind of mentioned earlier, this whole thing is optimized for analytics. So it's different than standard blob storage in that it's blob plus some things. So that was the first move, is to kind of build this tight integration in with Data Lake. Next was to expand the platform to cover, well, essentially all the platform services that we need to be able to manage. So we have our general management of this environment, we have our security management, we have monitoring of it, and then we have this concept of a meta store, which is kind of our ability to describe things in our data lake and elsewhere in our environment. But it's a meta store is all part of this platform. We then layer on a data integration layer into this. So what does that mean? That means Data Factory is now built into Azure Synapse. There is no distinction between them at this point when we're talking about a Synapse workspace. It is built in, and it's just a first-class citizen inside of the environment. So we have full data integration support. Next, we expand our runtime capabilities. So we already had SQL here. That was the data warehouse aspect of it. But we've expanded SQL to include an on-demand offering, which I'll get to in a second. And we've also expanded to include an Apache Spark offering. So we have our relational data warehouse world, and we have our big data world, all under one umbrella. And again, all of these things are available through this single point for management. So we have management, security, monitoring, and Metastore that spans across all of these components. So I mentioned this a little bit a second ago, but we have some new form factors in which these analytic runtimes are deployed. We have a provisioned model. This is where we predefine what our clusters are essentially going to look like. And then we have a serverless model, which is this on-demand model. And I'll be covering this quite a bit when we get into the demo. Last, we have a expansion of language support. So again, traditionally, SQL Data Warehouse only supported SQL as a development language, but we've now expanded that we have a lot of different ways of attacking this data that lives in our Synapse environment: SQL, Python, .NET, Java, Scala, R, so on. So we have languages that are suited to different roles, suited to different workloads. It just is a much better environment for being able to attack this. Your data scientists don't necessarily need to learn something new. They can apply their existing skills right here. Speaking of that, the last major component here is Azure Synapse Studio. This is the development experience. This is what we will primarily be demoing today that sits on top of all of it. This is the central portal to manage and develop in this environment. So to me, the most important aspect of it is this last thing. This is designed ultimately for analytic workflows at any scale. So that at any scale is the important side. And I'm not so worried about the far end of this scale being workloads that have petabytes and petabytes of data. We already had a number of solutions that were optimized for those type of environments, things like Apache Spark and other big data solutions. What I'm more concerned with is on the small end of this. Azure Synapse opens up the door to have a world-class data warehouse environment for even the smallest of organizations, whether they measure their database sizes in megabytes or they're on the large end, again, measuring them in petabytes of data or something like that. It scales across all of those. And we are, as a consulting firm, deploying it for all sorts of different clients. And many of them are on that smaller range because this opens the door for them to do things that they never, ever had the capability of doing before. And we talked, again, about modularity. That's an important aspect. If I'm a small organization, I likely don't need something like Apache Spark. But having this framework in place that as I grow, I can just add that as a module is huge. It really does open up the door. And so these things, management, security, monitoring, and our Metastore become universally available to any organization side. So one more thing I wanted to mention, because this is new or relatively new. Again, it popped up in the last couple months, and it's not reflected on these other slides, is a new feature of Cosmos DB called Synapse Link. And Synapse Link allows us to take a Cosmos DB, again, a transactional data store, and we're specifically, if you're not familiar with what Cosmos DB is it exposes a number of different types of APIs for your use as a data platform. Things like a MongoDB API, a SQL API, a Gremlin API for doing more graph type databases. And when we're talking about Synapse Link specifically, we're talking about either SQL today or MongoDB today. But I can take that existing transactional store that is optimized for globally distributed transactions that are row optimized, and I can create an automatic analytics store copy of it that automatically syncs in near real time. So it reduces my complexity. There's no ETL to be able to do this transformation over to a column store. There's zero impact on my operational workloads. It's all done in the back end. It's transparent. It's just part of the service. It's optimized for very, very large scale. So again, this is something that's globally deployed across Azure's global network. So I can have replicas in all the different regions. I can have them sync to all the different regions and have the data natively close to where my users live. And it's largely cost effective too, because I am eliminating the need for additional services to be able to perform this analytics store copy. So this is pretty new, and we'll look at an example of how it integrates into Synapse here in a moment. But it's a really cool new feature because it's just an automatic thing that takes our operational data and gives us an analytic view. So how does this transform our architecture that we talked about earlier? It doesn't largely transform it. Most of these components are still the things that we talked about earlier. But how it transforms it is now this is all under that single umbrella of Synapse. So all of those components that we looked at earlier are all under this single umbrella. We have our pipelines, which that's again the equivalent of Data Factory. We have this Synapse SQL, which is either the equivalent of the data warehouse or it's the serverless that we'll talk about. We have Synapse Spark, which is kind of that replacement for the Databricks we had in our previous model. And it still ultimately kind of flows down to some visualization engine. And Power BI is also integrated into this environment. And it sits all on top of Data Lake. So let's jump in and actually take a look at this. Give me a moment to switch. All right, my screen should now be shared. This is probably going to be pretty small for most of you, and I'll do some zooming in. I do need to do one thing before we get started. I need to turn on some of these Elastic services because I have them pretty aggressively set to turn themselves off. And so we'll get them started up so we can actually query them when it comes time. All right, so first thing we want to look at is I am just in the Azure portal, and I'm looking at the resource group that I have that's managing this environment. So all of my resources are here, and I'm not really going to go into a lot of details here, but what I want to show is kind of the components that I have as part of this demo. So first I have my storage account to talk about. This is my data lake. So this is an Azure Data Lake enabled storage account. I have my Synapse workspace, which this is that umbrella that I was talking about. So this is where we're starting to bridge across all of these services. This is no longer just a data warehouse component any longer. This is all of those aspects under that single umbrella. And we will go into the Synapse Studio here, which is part of this workspace in a moment. I then have two different compute pools that are deployed as part of this Synapse workspace. I have an Apache Spark pool, and then I have a SQL pool. And this SQL pool is that equivalent of the SQL Data Warehouse. So the last couple things just to talk about here is I have Key Vault. This is acting as a kind of a secure store for any credentials that I'm using in this environment. And then I have a Cosmos DB just to show the link between Synapse and Cosmos DB when we get in there. So let's look at the workspace. There's not a whole lot of things to kind of talk about here from a high level perspective, but this is where you would go to launch your Synapse Studio. And it's just this link here that brings you to the workspace. The other thing just to talk about is while I have a single SQL pool and a single Spark pool here, I can have many of those. So I can have this as a distributed workload. If I have a really big environment, I can manage the size of these inside of here as well. But for our demo, it's pretty small. So let's hop over to the environment itself. And I'm going to zoom back out just so we can kind of see this as a whole. So when you log into your workspace, you will be greeted with something along these lines, where you have some help features that kind of get you started into building an ingestion engine. So this again is our data factory where we're pulling in data. We have our kind of explore pane that we're talking about where I actually can query this data and look at it, analyze, which will tie into some of our SQL queries and Spark and that sort of thing, and then visualize. So these are kind of those pillars we talked about from the architectural perspective, all just kind of codified here inside of this portal to help us go through it. And you're also given a number of kind of helpful links to help you get started. For instance, this Knowledge Center, if you're brand new to this, is a good place to start because it does contain sample code that can walk you through some of these concepts, and then you can kind of play around with it. But what we are going to focus on is kind of the functionality hidden inside of here. And so let me zoom in. I have a menu over here on the right. Again, right now we're in the home, and this home is just kind of a landing zone for you. And then it's organized into a few different parts. We're going to start at the bottom. We're going to go down to the manage section. So what do we get in manage? In manage is all of our various components that we have linked in this environment. So again, this is our umbrella that's covering this. So this is where our SQL pools are listed. So again, I have a DW400 here. This is my data warehouse. And I also have this on-demand instance, which again, I keep alluding to, but we will get into here in a moment. So these are both parts. They're both online now. I have an Apache Spark pool and more. So linked services, this is to me where it starts getting interesting. This is where you start getting some of that modularity. I have a number of linked services kind of linked here, already pre-configured. I have that Cosmos DB, I have that Key Vault. But if I go over here and go to new, I have the ability to essentially connect to anything that Data Factory has capabilities to connect to. So I have, I don't know, somewhere in the neighborhood of 90 different database platforms that I can connect to. Plus, I have a number of generic things like ODBC, REST, OData, that sort of thing as well. And generic from like a file perspective of just individual files and things that I can connect to, like, an SFTP as an example. So any of these things could be added here as a linked service. Once I've established it as a linked service, I have the ability to interact with that data, potentially query that data, pull that data into my data warehouse, do a large number of things through this kind of interface. And so it ends up being a pretty powerful tool for us to be able to link all of these services together. Again, going down the line, next is my triggers. These are just our pre-scheduled triggers that we may have for running any of our integration jobs, our ingest. These could also be event-based, so it could be something like a new file is created in our data lake. I automatically process it. Next, we have integration runtimes. If you're familiar at all with Data Factory, this is the same concept. I have integration runtimes to be able to access data that is in private networks. I don't have any configured here other than the one that automatically comes with the environment, which is the auto resolve, which only really works for publicly accessible data sets. Could deploy runtimes here that would allow me to get to private data within my private network or within, let's say, like a third party like vendors network or something along those lines. Not going to go a lot into access control, but the access control here is managed through Azure Active Directory, but this allows me to kind of apply Azure AD groups, either in here or individual users, to these kind of named roles. We have an admin, a workspace admin. That's the admin for this entire environment. And we have one for Spark and SQL. Next, we have the ability to actually store credentials in here, the username and password. So when I say store credentials, technically we're not storing the credential. The credential is stored inside of something like an Azure Key Vault. So that's what I'd actually be linked here to, as an Azure Key Vault. But this brings it accessible to any of the other services that are inside of my Azure Synapse environment. So they don't necessarily have to know how to talk to Key Vault directly to be able to access these credentials. Moving up, we have our monitor. So this is where we monitor our environment. So we can monitor things like our Spark jobs that we have. Like we have one that's in progress right now. That was me starting up that Spark environment. Any SQL requests that have kind of gone through, which I don't think I've had any in the last 24 hours. We can debug data flows. All of our monitoring and debugging of our Data Factory environment also shows up here. So let's get into some of the meat of this. I'll zoom in here again so we can see this. But what we have in this data section is this is going to first off show any of our pools that are living inside of our Synapse environment. So this is my Spark pool. This is my data warehouse, which I think I have some data that's published out here, maybe. But this will actually connect to that pool, and it'll allow me to query it and so forth from here. And so there's a bunch of data that's inside of this. I then here have that on-demand instance. So I keep on alluding to it. So now it's time to actually talk about what the on-demand is. This on-demand is a SQL pool that's available to me on demand, as the name implies. So I don't manage it. It's managed as part of this service. It's always on. How I pay for it is based on the amount of data that I am querying through it. I think it's somewhere in the neighborhood of retail, like $7 a terabyte of data that's been processed through it. But it allows me to query just about anywhere inside of my ecosystem. So specifically, what do we use it for? It allows me to query data that's inside of my data lake. So I have files in my data lake. I can query against them. This is a game changer for a lot of small organizations. It also has a lot of benefit to big organizations, but why it's a game changer to small organizations is because I have the ability to develop a virtual data warehouse using this. And in fact, that is what I have here. I have this worldwide importers, so a sample database from Microsoft. It's a dimensional database that is represented here by a series of files. And all of those files are mounted as external tables inside of here. So they are just files living inside of my data lake, and I can query them. So let's do a quick top 100 query on our cities dimension. And this will come up here in a moment. So if I run this, it is going to spin up that SQL instance. It's going to basically refresh that. First time you do this, there is some overhead of getting all of this stuff started. But then it's going to go out there to my data lake. It's going to query across those files, and it gives me a returned data set. This supports almost a full SQL syntax. Most of the things that it doesn't support are things that actually materialize this into objects inside of the database. But I can run functions here against these. I can do aggregates against it. I can do just about anything I can do inside of a SQL server against a file-based database. I can even utilize this to do my exploration, and then I can push this data from here into a more formalized data warehouse. So the performance here is not spectacular. It took about 10 seconds for it to query that. But that's not typically how we would use this. We're not going to use this usually unless we're doing exploration. We're not going to use it usually as an interactive querying tool. We would utilize this to be our virtual data warehouse backend for something like Power BI. So Power BI once a day does a refresh of this data against our virtual data warehouse, utilizing this on-demand SQL server, pulls all of that data in memory, and now we have a very, very speedy interface because it's an all in-memory version of this that I can report across. And I did not have to pay for any infrastructure to do this. Well, you have to pay for the data lake side of it, but very, very small amount of infrastructure needed to be able to do this. This is where I'm talking about Synapse has that ability to support very small organizations as well as big organizations. So I have an entire virtual data warehouse here without having any SQL Server infrastructure to maintain. It's a very kind of cool option that wasn't available to us before in this kind of environment. Let's close and discard that.
Pierre, would you talk about what are the compute costs here for that sort of thing?
So the compute cost is going to be that the query times again, and based on my memory, I think it's around $7 for every terabyte of data that's processed by that query engine. And so what I'm doing here is a pretty small database. It's measured in hundreds of gigs max. So it would take a lot of data to even breach that $7 mark for it. So that's the kind of the compute cost to it. It's very, very low. Again, though, don't expect spectacular performance out of it at all.
Right,
Does
but
that
you said
make
if
sense?
it's just a daily refresh you need, then you're not that concerned about how performant it is on an overnight refresh, for example, right?
That's correct. Or, like I said, I'm doing data exploration. I just dumped a bunch of data into my data lake. I don't know what's fully there, so I want to query it and kind of look at it and find out what's of actual value. I don't really care that it takes 20, 30 seconds for that query to return, because ultimately I'm going to take that data and I'm going to move it into a more performant platform at some point anyways, if I'm going to do that kind of interrogation against it. But this allows me to land things in my data warehouse or my data lake with low cost and worry about the kind of the format of that later.
Got
And
it.
so let's actually jump into that. So I'm inside here in my data tab. I'm looking at what's stored inside of my workspace, but I also can see my linked resources here. So I had two specific linked resources that we looked at just briefly earlier in that management area. I have my Cosmos DB. So this is a live Cosmos database that has that analytics copy of, in this case, it's a MongoDB document. So it's a plants document. This is getting sensor data that's fed into it. And in near real time, that data is getting converted into a columnar database that I can query and look at inside of this environment. It's just mounted. I can now query it. I can actually even go to an action. I can say, do a new SQL script against it. But what I want to look at here quickly is our data lake. So my data lake is attached. Again, I just have one attached, but I could attach many different storage accounts to this. So if I bring up my landing zone, which is my kind of base of my data lake here, I have this worldwide importers database. So this is this virtual data warehouse that I have. So if I go into that table that I was querying, that dimension city table, what does that consist of? Well, it consists of dozens and dozens of text files. These are tab delimited files. I'll tell you right away that that is not best practice. That is not how we would want this to be if we were trying to make this performant. We would likely take these text files and convert them into something like a Parquet file. That's going to give us much better performance from that on-demand instance. But this is essentially any of file type can be mounted, whether it's delimited, whether it's like an ORC file or a JSON file or a Parquet file. I can take those and mount them as tables inside of my on-demand instance, and then I can query across it. And so that simple query that I did, it just said give me the top 100. That is actually spanning all of these files. It's querying across all of them to give us that data back. The last kind of thing under here for linked are integrated in my integration data sets. These are data sets that are defined as part of my data factory jobs, which we'll get to here in a moment. But let's go up here. Next, I want to kind of show this development tab. So this is our primary kind of IDE for development inside of this environment. This is also an example of our meta store here. So I have things stored in this Synapse environment like canned SQL scripts, canned notebooks, data flows, other things. If I go up to the little plus here, you'll see the type of stuff that I can create. So I can create new SQL scripts. These SQL scripts could be against my on-demand instance. They could be against my data warehouse. I can create new notebooks. These notebooks get attached to those Spark instances. I can create data flows. If you're not familiar with data flow, this is essentially a visualization engine, similar to like SSIS, that uses Spark in the background, but it allows me to transform data in a visual way. I can do Spark jobs, and I can even browse a gallery to bring in like samples or import things. So we're going to look at one of these notebooks that I already have open. I have a bunch of notebooks to do different demos in here, but this notebook, let's collapse some of this down because I'm zoomed in pretty far. This just shows an example of using Spark for some of our data integration. And so what I'm doing here is I have a Spark job that's actually going out to Azure's open data sets and grabbing a list of public holidays from essentially a data lake that Microsoft is maintaining. And I'm grabbing the last 6 months of these public holidays. And so I will kick this off. It's going to go run this job, and it ran it pretty quick. By the way, if you're not familiar with this concept, notebooks are primarily kind of a big data concept, although they are used in the data science world and elsewhere as well. But for kind of our purposes, they tend to be more organized as a big data concept. And it's a way of having a narrative wrapped around a set of commands. In this case, these are cells that I am issuing. These commands can be done in a number of languages. What we're looking at here is PySpark. So it's Python written for Spark. And I'm not going to go through all the code because that's not the point here. But what I did is I brought all of the last 6 months of holidays in. I'm going to show that I got it by running this and grab the last the first 5 rows. So it's going to go execute it. There's our 5 rows. Let's continue to scroll down. I am now going to write that data, or start to write it out to my data lake. So first I am configuring my data lake. I'm just giving it the parameters of where this lives. So important to understand, because I'm in my Synapse environment, all the security is handled for me. I don't have to do any security pass-through. There's automatic Azure Active Directory security pass-through. I am going to create 3 different files. I'm going to output it as a Parquet, JSON, and a CSV. And I'm just getting the paths right now for it. This is where I'm actually going to write it. So it's running a job now that's going to go out and write these files. And it should go pretty quick. But do keep in mind that this is a demo environment, so everything's really, really small and from a configuration perspective here. And we can get details too by what it's doing. And so it's running these various jobs and doing it. So it just succeeded. So let's go see how that has succeeded. We're back in the data lake now. I'm going to go to where this is outputting, which is this Spark out. And I have 3 files that were just written. And if we look at these files are, they're partitioned out. I only have a single partition, but they are partitioned out. So if I right click on this, I can do the same thing we saw earlier. So I'm using my SQL on-demand instance here, and I'm doing a select top 100 from it. And this is just a connection to that file. You notice I am not defining any sort of structure because Parquet has built-in metadata. So I can just run this, and it'll go out and it should give me the top 100. And again, I'm trying to be very clear with you guys that this is not, when you're using these on-demand instances and stuff, meant to be particularly performant, right? This is things that are meant to be a little slower, but it's meant to span very large amounts of data potentially as well, because this could be terabytes potentially of data that is spanning across. And there is absolutely an overhead. We'll continue down with the rest of this script while that is loading though. So our next kind of job here is we are going to do a tab delimited as well. And I'm creating a data frame for that. Again, we won't get into what that means, but I'm outputting that as this new file there, and I'm going to save it as a text file. And this will take a moment to run too. So let's go back up, see if this completed on us. Oh, it's still running. But we should see this soon here too. There's our text file that was output. So that was not there a moment ago. Similarly, we can use this environment to actually read. So I am reading this data into this variable, creating some data frames from it, and I'm just doing it from the 3 different files. And so we'll get those going. And we have this one. And then finally, we have one from it. So we're just reading from these various files, loading it into memory. It's not a spectacular demo by any means. It's just to show you that it's pretty easy to interact with this. We didn't have to deal with any sort of security. It's all automatic for us. All of this is using our Spark instance, which is it's a pre-provisioned Spark instance, but it only is running when we're actually pushing queries through it. Otherwise, it auto shuts itself down. I think I have it set to automatically shut down if it has no activity for 15 minutes. And then it will give us our results. So here's our results, by the way. And it did take a fair amount of time to return this, but this is our result set from that Parquet file. Let's close some of these out. Hopefully do this. Kind of our last thing to show here is our integrate pane. Our integrate pane is going to consist of our data factory stuff. This is where data factory primarily lives in this environment. And you'll see if I go to the new, I have the ability to create a new pipeline, or I can use the copy data wizard, just like you have inside of data factory if you're all familiar with it. So if I open this up, I have just a very, very simple example here that is taking a JSON file. It's actually a JSON file that is coming from that Cosmos DB, and it's going to save it into the data lake as a Parquet file. And I'll just execute this now. Run. Sorry for the jumping around, but the zoom is kind of a pain. So it's in progress. I'm in the monitoring section. I'm monitoring my pipeline runs. And it succeeded. So I'm going to go back over and we're going to look in our data lake. And it should have created in this manufacturing, this plants.parquet. And again, I can do similar things with this. I can query this. Notice I also have an option here to create this as an external table. So I can mount this directly in there. And when I mount that, it would show up as a table under this kind of external tables. By the way, since there's a metadata store around this, I can create databases in MySQL On Demand. This is a named database of worldwide importers. I can write just a standard create database, SQL command in here to create a new database, and it just creates it virtually. It doesn't actually exist. It's just the metadata around it, and then I can start putting objects inside of it. So I have these objects here, which are things like these external tables, but you can also define things like schemas. You can define views, all of that sort of things. And our types of external resources are defined here too. So I'll have an external resource defined in here for my storage path. So that worldwide importer storage path, that's the path inside of my data lake where this data lives. I also have a file format defined in here. This is what describes this tab delimited text file so that I can then easily mount that as an external table. And here I have an external like schema and things like that. And I can apply security at these levels as well. All right. That is essentially it in terms of demos, unless you guys have some questions about something you'd like to see inside of here. Keep in mind, this is absolutely not meant to be any sort of deep dive inside of this environment. If you are interested in more around Synapse, especially some of these features that we looked at, maybe like some of the syntax around the SQL and stuff, I would be happy to do more of a deep dive session for you guys at a future date for another user group meeting or something along those lines. The purpose of this talk is just kind of set the field for what is a modern data warehouse. How is it different than that standard data warehouse? And where are things going here? And what is maybe important to pay attention to in these environments? But again, it's not exhaustive in any means. It's just an introduction. So I'm happy to take any questions you guys may have. Nothing? You guys can't be bashful. Come on, spit something out.
Okay. Oh, there we go.
So the question is for something like PySpark that I was demoing, do you use it for data science or ETL? It's really based on what you're comfortable with. So me personally, if I was doing ETL in this environment, I would likely be using the data factory features. I would use the pipelines. I would use things like data flows to move through it. But if I am not familiar with that, let's say I was more on the data science side, or I'm more fluent in the big data side with Spark and so forth, I may use a notebook for it. The other side, if I go back over into these notebooks, is that as I kind of was explaining, that the notebooks give us this ability to present a bit of a narrative along with this data. So if I go into, I'll just pull up like this notebook. I have the ability to embed pictures inside of here. I have a whole bunch of stuff that I can do. I can also take this and put visualizations inside here too, not just tables of data. I could have graphs and charts. I can even mix and match that. It doesn't have to be all PySpark, for instance. That I could have most of this be PySpark, but maybe one of the cells is running some R to create a visualization. So in that scenario, I may be utilizing a notebook here because am doing some sort of narrative. I'm telling a story, not just exploring the data or not just transforming or doing some sort of the ETL. So I can't really, answer it as, do you use it for one or the other? It really depends on the scenario. There are situations where you would use it for ETL if that's what you're comfortable with, but more than likely, you're going to be using this for either building out a narrative or building maybe more of a Spark job where I'm doing some machine learning or data science type of things. I don't think you would typically be using the Spark side of this for your actual ETL. Any other questions? And again, keep in mind, we do have a number of language options available to, we talked about it earlier, but we have everything from, Spark SQL in just this environment to Scala to, C# and so forth. And we have other languages elsewhere. If I'm more comfortable with doing everything in SQL, well, then maybe I'm doing my transformations using some of these SQL scripts. And we didn't go into a lot of this, but if I pull up an example here, and I'll zoom in again. This SQL statement right here is doing a copy into, and this is copying into my data warehouse in this case. I'm copying data, and I'm doing it from an external data source. This is a publicly available blob from Microsoft. Microsoft maintains a data lake of New York taxi information, and there's a bunch of information in there, everything from sensor data based on their GPS locations for routing to just information about the number and the fare amounts and those type of things. Well, I have the ability to connect to that, even though it's not part of my direct ecosystem here. It's an external thing. Connect to it and load it directly into my warehouse. So utilizing something like SQL, I can do ETL. It does not have to be any of the other tools. It's what I'm comfortable with or what maybe is the best thing for the job. So there's a lot of, again, different ways that we can kind of utilize these things. So here's another example of using an on-demand query in this case. And this is going out against the New York City taxi information. And it's pulling from this yellow taxi cab information. And you'll notice I even have some embedded parameters inside of here. I'm pulling in year and month and then name. It's Parquet format. I'm doing a filter based on that file path. I only want 2014 through 2019. Again, this data is external to my environment. It lives somewhere else out on the internet. So if I run this, this is going to go out and it is going to aggregate the essentially the number of rides per year based on this external data. So this could take, some time, because this, for one, this is a very large data set that it's going out and querying against. But two, it's having to reach out to the internet to do this. But that capability is here, and it's fully here for being able to do those type of integrations. So here it is. So it aggregated it by year. You can see the number of rides per year. I have the ability to graph this inside this interface too. So let's say maybe I want more of a bar chart for this, or actually columns, probably better. In this particular data set, you can see that it goes down. I really just want current year. It goes down over time. Actually, no, one. Right. So we can see that it kind of goes down over time. And this data set is actually telling a story about the impact of ride sharing services like Uber that they've had on the New York City taxi service. They've gradually been losing rides every year since things like Uber have been approved. But there's a bunch of things that you can do with this kind of a data set. Any other questions before we wrap up? I think we have a few minutes left.
Pierre, this is amazing technology, and like you said before, one of the most remarkable pieces of it is that it's a game changer for small businesses. And I'm just curious, when in a small business, and this is not really a technical question, and it's not necessarily for you, it could be some other members, anybody on this meeting. When you have in a small business, you may not have a fully developed IT organization. How does one begin a conversation about the opportunities that this at Microsoft's modern data warehouse architecture provides?
Well, I can, give you a consultant's perspective on it. The main way that we are approaching this with our clients is through kind of quick to deploy proof of concepts and pilots around it. So we take a business problem that they're trying to tackle, or something that's been difficult for them to tackle in the past, and we will do maybe a 2-week proof of concept in this environment to bring it in to just show some of those capabilities of maybe centralizing data in a single place if they don't have a traditional data warehouse. It's not something that they've done in the past, or just showing that ability to take this from start to end and make it land in something like Power BI as an example. That's usually where we start. If we were doing this in that kind of traditional world, it's really hard, like I said, to get to that ROI in a 2-week period. It's not impossible to do it. And so we're using that agility of this platform to show value right away. And the client may still look at that and say, yeah, well, that's nice, but we're not really ready to adopt that. And that's perfectly okay. But that's typically how we are approaching it with our clients, is through these kind of quick efforts. So is the platform more ad hoc, rad examples? It can be very, very ad hoc, but it doesn't have to be. We can formalize any of these workflows, any of these processes through it. But certainly one of the advantages of it is our ability to take advantage of this kind of ad hoc, or what we would, in kind of today's terms, we would talk about it as that data exploration. So that ability to land data very quickly, explore that data, find some sort of value, and then push it out to some sort of deployment, and usually it's Power BI or something like that. That round trip, that kind of life cycle we talked about, is again something that's usually managed in weeks, not months. So we can go from something like that to an end product, maybe not a complete end product again, but something that has value in a very quick amount of time. But it's not necessarily meant to be an ad hoc platform. Ad hoc is kind of just a consequence almost of the platform, or maybe an added feature or benefit of the platform. But ultimately, our goal would be to formalize those pipelines so this goes into some sort of certified data set that is being able to be reported on. And that's a completely different conversation to have too, because we can talk about how to structure a data lake, because it's very, very easy to go from that data lake to a data swamp very quickly if we just start dumping data in there. So how do we kind of manage the governance around those things? Again, that's a full conversation on its own right. But certainly the ad hoc aspect of this is an advantage to us to be able to deploy things quickly and demonstrate value quickly. So I have I know we're probably right on time now, but I do have a question for maybe the group if someone wants to answer. Is anyone utilizing any of this today? I wish, yeah. Well, to give you, as you guys kind of think that over, please free to put answers in the chat as you think about it. This entire demo environment, all of the development work I did in here, and some of this data is quite large. It spans gigs and gigs of data. It's not terabytes of data by any means, but the whole environment to run has cost me maybe around $20. So someone mentioned that they're in an AWS ecosystem. I can kind of give you an anecdotal type of example of how we work with AWS in this environment. I have a large client that is primarily in AWS as well. In fact, they have their primary data lake is based off of S3 storage in AWS. However, their business intelligence has primarily been in analysis services and using more Microsoft technologies. We used Data Factory to do forklifts of data from AWS into kind of a mirrored data lake on the Azure side that allowed us to then push this into their cubes on the Azure side. And we were able to get some pretty spectacular performance where we were copying over, I don't know, tens of terabytes of data in a matter of just a few minutes using some pipelines. Now, I say that it's absolutely possible, but when you start looking at those type of numbers, you're talking about really expensive pipelines too. But it is capable of pushing data over very, very rapidly. Also using things like we see here, where I'm connecting to this external data set. This could be an S3 storage. This does not have to be Azure storage. I could connect to something in S3 and pull that data and still query it in this environment. Of course, when I have external environments, that is going to lead to potential performance issues. But it's possible that you don't have to be, set on Azure to use these features. I can have more of a hybrid cloud environment and still take advantage of these things. Right, if there's no other questions, I think I'm done.
Thank you so much, Pierre. This was fantastic. I'm going to go ahead and post the some of the links from the start of our conversation. I am also, has been recorded, and I'm going to do my best to get that posted up to the BI user group site. I thank you all for attending and have a great rest of your day. Thanks again, Pierre.
Thank you, guys. I appreciate it.
Thank you.
Great lecture. Thanks.